We're good to go.
Okay. Hi, everyone. Welcome to the room. I'm Devanshi Joshi, Senior Product Marketing Manager for Serverless on Azure. And we are here today to present on build an intelligent Python app with no infrastructure hassles. With me, I have Anthony.
I'm Anthony. I work on Azure Container Apps.
All right. So before we go deep on what we'll be covering, let's see what we are developing in this session. So we'll be developing a Python RAG app with a chat interface powered by LLMs, and we'll discover what it takes to build it locally, take it to the cloud, and the concerns of running this LLM-powered RAG app in production, and how do you overcome it. So before we see the local version, let's see what the end product will look like and how we're going to go on the journey to develop it. So this is a Contoso Electronics company, and we have an internal chat bot for the employees to learn more about it. So the company is involved in electronic sales. Let's chat a little bit on what are the different roles in sales. Let's see.
Do you need me to hold the mic?
Yes. Okay, it's thinking. And okay, so we see the different roles that exist, and I want to know who is the VP of sales, okay? It's thinking. It thought a lot, but gave out
Yeah.
quite a bit.
It knows everything about the VP of sales except for the name, because we actually didn't include it in the document.
So basically, this chat app is fed a document to provide the augmentation for the LLM to learn more about the context of Contoso Electronics and be able to give rightful answers. All right, so let's go back to seeing what it takes to build this out, right from the local version. Over to you, Anthony.
Okay, sounds good. So there's a few parts to this application. So what you just saw there was the web UI. And today we're using LangChain, but we could use other things like Llama Index or Semantic Kernel or some other, there's many frameworks out there these days. And the UX, or the UI itself, is powered by Chainlit, which is kind of like a really easy way of building a chat interface. It's built on top of things like FastAPI. And yeah, we'll kind of see how easy it is to use if you haven't used it already before. And for the demo, we're going to talk to basically use Azure OpenAI as the LLM. But we can actually also run Olama locally on my computer, although I have a pretty old computer, so I'm not going to try that here. I figured if I mention enough times that I have an old computer, eventually I'll get my computer replaced. I don't know if that's true. And also, if we want, we can actually use a third-party LLM as well, whether you create them or kind of use them just by going to them directly, or you can actually create those in Azure as well using Azure AI. So another thing that our application uses is a vector database. And that allows us to store vectors, as the name kind of implies. So it kind of allows us to basically take the PDFs that we kind of just saw before and kind of chunk them up into different bite-sized pieces and save them in a format where we can actually compare and kind of find relevant information given another piece of information. So a vector database is really good to do that. So we're going to talk about how we can calculate embeddings and use that to store vectors into the database so that we can, when we ask the chatbot questions, it can basically go and query for relevant information and then make sense of the answer. And then to load these PDFs into the database, we are basically just going to have a Python script that will parse the PDFs, chunk them up, calculate the embeddings, and then store them in the vector database. And this, I think, is probably the most basic kind of setup that you can have for RAG. So we want to kind of start with this kind of architecture so that everyone can kind of follow along, and then we can see how to run these locally as well as deploy them to the cloud. Cool. So we're going to look at code. And feel free to interrupt me if you have questions. And also if this, like we have a pretty tiny screen up here, so let me know if I need to make things bigger. I'll try my best to zoom in where I need to.
Yes, for the code.
Oh, we can dim the lights? Oh, so nice. Okay, well, let's keep going while that's happening. Thanks. All right, so I'm just going to walk through the app so that we're all kind of on the same page about what it does, and then we're going to run it locally. Whoa, okay, it's dark. Yeah, so we're using LangChain. You can also see that I'm bringing in Chainlit. And so every time the, like basically a new chat session starts, we're going to call this function. And this part here is talking to Azure OpenAI, or basically configuring Azure OpenAI. And you can see I got some little extra bits up here about getting a token, because one of the goals when we deploy this to the cloud is that we actually don't want to use API keys, because if that gets compromised, then anyone can take that key and use it. So instead, we want to use an identity to authenticate with Azure OpenAI in this case, so that we have more fine-grained control about who can actually access the application. So that's kind of what this part is doing. It's basically calling this thing called the default Azure credential to create a token, and then we're going to feed that to Azure OpenAI so that we can talk to it. And default Azure credentials allows you to basically it handles a lot of stuff inside. So when I run this app locally, it's actually going to probe at different parts of my machine, like my Azure CLI or Visual Studio Code for my Azure login. And then it's going to authenticate as me when I'm running this locally. But when I'm running it in the cloud, it's actually going to use the identity of the application that is running under. So just by writing this line of code, it's able to handle all those situations. All right, so the next part is I'm basically setting up a retriever tool. We'll look a little bit more into this tool in a bit. So what we're building is that we're building what's called an agent. So, and we're actually using a React agent. So this agent basically will basically form a thought or multiple thoughts, and then kind of come up with actions so that it can try to figure out the answer for what you're asking. So in this case, we will pass it some tools. And the tool that we pass it right now is the retriever tool, which will actually query the database. So basically what the agent will do when you give it some information or basically ask it a question is that it'll be like, hey, like what tools I have access to, and then it kind of will pick the right tool, hopefully, and kind of like basically call that tool, and then the tool will do the right thing. So in this case, when it thinks it needs to search for information, it's going to go and use the retriever tool to do it. And then after that, we're just creating an agent executor, and then that's about it. And then every time we get a chat message, we're just invoking that agent. And then we're just passing in the message content, and then we're just displaying the result. So that's, that's all that there is for the UI itself. And I kind of promised that I would go a little bit deeper into the document store. So if I F12 on this. So yeah, for talking to the database itself, I'm just basically using the Quadrant client that comes with LangChain. And within it, it's basically just using the Quadrant client behind the scenes. I forgot to mention that the vector database that we're using is Quadrant, but we can use other things too, like Weaviate and Pinecone and things like that. And then the only other thing that I'm really doing here is I'm creating a new collection, which is basically, think of it as almost like a database table, but not really, if it doesn't exist. And then another thing I want to call out is that we're using embeddings from Hugging Face. So this is the model that I'm pulling in. And whenever we are trying to basically save information to the database, basically save a vector, or basically a vectorized version of a document to a database, we'll basically call into this model to calculate the embeddings. And the vectors or embeddings are basically just a list of numbers, and we're able to kind of compare them to kind of figure out what's similar and what's different whenever you're given some input. And then when we're actually given an input, so if somebody asks a question, we're going to do the same thing. We're going to basically calculate the embeddings, and then basically call in the quadrant to basically bring back the top 3 or 5 most relevant parts of the document, so that the large language model is able to figure it out, or kind of like read through it and kind of come up with the right answer. So I think that's I think that covers kind of like RAG in a nutshell. And what I will do here is I will actually run the application locally. So before I do that, I actually need to start up Quadrant. So in order to do that, I am using Docker. So it's always at the bottom of the screen here, but it's going to go to the top. So I'm just using Docker run Quadrant. So I'm just using that locally. It's going to take a moment to start up. Longer than before, so I'm a little bit worried. But it's working. Okay. Cool. So now I can start my app. So I can go chainlit, run, and then my chat app. And then I think this is the RAG one. And then let's press enter. It's going to take about 10 seconds to start up. And while starting up, it's loading my environment variables, as well as the model that we're going to use for embeddings. I think it's doing that right now. So we're waiting. This is all taking longer than before. Okay, here we go. And it's going to automatically open my chat interface. So now I can ask it, what is the name of this company? And hopefully what's going to happen is that it won't know the answer because we didn't give it any documents yet. I just basically spun up Quadrant without without kind of putting any data in it. There we go. It actually gave a very useful answer. So it's like, figure it out yourself. And I guess that's what we're going to do. So we're going to go back here, and we're going to take a look at our job. So this is basically a Python script that we can run. And all it's going to do is it's going to look at a directory for some PDFs. And then it's going to, somewhere down here, we're going to load and split them. So we're going to load the PDF and then split them into chunks. I think chunks of 1,000 words, I think. And then we're going to go and calculate the embeddings and store them in the database. And because we're using LangChain, a lot of this stuff is already done for us. So somewhere down here, I am just calling add documents. And within that, it's actually, it knows how to talk to Quadrant. It knows how to take the different chunks of the document. And then it also knows how to talk to the embeddings model that I have running locally to calculate the embeddings and store them. All right, so I'm going to quickly run that as well. Oh, I just killed my app. That was not the button I wanted to press. Well, let me start the app up again. And while we're doing that, we'll run the embeddings. OK, so it's going to go and run it. Hopefully, it's going to take about 10 or 15 seconds, because those documents are relatively small. But we can actually feed it some pretty large documents. So my app started up again. And please finish. Come on, you can do it. There we go, it's done. Okay, so now when we ask the same question, hopefully it'll give us the right answer. The suspense. And it got the right name. Amazing. So, and then you can actually expand and see what it's doing. So it's like, okay, I should actually use the search documents tool so that I can find the name of the company. And then all it's doing is it's basically calling the tool and asking for the company. And then once it got the answer back, it's like, oh, okay, I think the company's name is Contoso Electronics. But let's make sure. So it's basically going to do another query to kind of like learn more about Contoso Electronics, just to kind of double confirm that that's the name of the company that these documents are relating to. So yeah, so that's kind of running this locally in a nutshell. Hopefully I didn't miss anything. And we're going to talk about now how to deploy this to the cloud. And we have a question.
Yes, good question. So what difference did the chunk size make when you were loading the
So the question is, what difference does the chunk size make when you load it? I think it really depends. So what I've found was that depending on the LLM that I'm using, as well as like that would depend on the context windows, as well as the embeddings models. Like different contexts, the different chunk sizes work better in some cases. So in this case, I found that like with 1,000 and an overlap of 50, sort of worked okay, and I just kind of kept it at that. But I found that it did take a little bit of experimentation, because sometimes if it doesn't pull back enough information, then the LLM's not, it's not able to kind of make sense of anything. But if it pulls back too much, sometimes like it actually exceeds the size of the context window.
All right, so let's see. When we take this to cloud, what are some of the considerations and factors we need to take care of? The spectrum of application hosting varies between control and simplicity, and it really comes down to the philosophy of your development. Is it opinionated, more open, less opinionated? And you vary that from virtual machines to all the way to low code. And all of these form the building blocks of a solution. So app is, yes, the core and the center of your solution, but along with it comes AI, databases, DevOps, and taking components of your solution in the cloud as well as the edge, all of this together, because a real-world app has so many different components. So on Azure, when we talk about least form of infrastructure for the application, we try and go towards the serverless or the pass route, and that is where Azure Container Apps or Azure Functions come into play. Now, developing intelligent apps with serverless compute is interesting. So Azure Container Apps, if we double click on it, is a serverless compute platform for you to build cloud-native web apps and microservices. And building on the foundations of serverless characteristics with least form of infra or operations management, highest form of abstraction from all of that. It's instant event-driven scaling all the way to high numbers and back to zero with no loads, as well as the staple pay-per-use billing model. And applying this across the variety of use cases for your solution is easy and quick to get started with, right from microservices, some backends, AI apps, and containerized web apps, event-driven managed containers, and more. So building out your intelligent apps really forms concepts of cloud-native app development, combining with cloud-scale data or generative AI to create those highly differentiated digital experiences for your end users. In that, there are different components that Azure Container Apps has to offer as the application platform of choice. So the foundation of the serverless compute really bears the base for these components to live and exist for your application in the form of apps, jobs, and vector databases like we saw as part of the app that we deployed locally. So apps as concepts are services that run continuously. So even if they say fail, the platform automatically restarts it. So you can run APIs, web apps, backends, all of that. Jobs are like they start, they do their unit of work execution, and then they exit. So they are finite run jobs, and they can be on demand, scheduled, or event driven. Like say you're running scheduled batch jobs, or you're running on-demand workloads, depending on a single unit of instance that comes about for your solution. And lastly, the add-ons for vector databases. We saw how locally, when Anthony was showing Quadrant come up, if you take this to the cloud and you had to manage it and deploy it and then call it out to your application, Instead of that, with add-ons, you don't have to manually download, maintain, and create it. Azure Container Apps offers it natively right next to it for your vector databases to be interacting openly and directly with your main application. So this is what was deployed locally. And now let's see when we take this to the cloud on Azure Container Apps, how does that look like? Anthony?
Cool. Yeah, so this is what we saw before, and let's see what we're going to do. So for the LLM part, we're pretty much going to keep it the same because we're already using Azure OpenAI. So we're going to use the same Azure OpenAI endpoint that I had before. So the other logos, I guess I should have gotten rid of them. They probably apply a little bit less, although I guess you can still, basically call another LLM that lives somewhere else or lives in Azure AI, something like Llama 3 or I forgot some of the other ones. Like Mistral Large, like those are some of the ones that we have in Azure AI. But today, I'm just going to use Azure OpenAI to keep things simple. And instead of my local file system, I'm using Azure File Share in the lower left corner there. So we're just going to put a bunch of files into Azure File Share. And then, as Devanshi kind of talked about before, you can deploy your intelligent apps, or basically your apps, to Azure many different ways. And with Azure Container Apps, we basically try to make sure that you have all the building blocks to deploy an app like this. So we're going to deploy the rest of the app to Azure Container Apps. For the main chat UI, that's basically a web server, so we're going to deploy that as a Azure Container App. And for the file indexer job, we're going to deploy it as a Container Apps job. The sample basically the example that I'm going to show you, we're running the job locally, but you can actually, kind of imagine running that on a schedule, or you can even have it respond to new files being added to something like blob storage, so that you can actually, on the fly process files as you upload them. And for the vector database, we're going to run that using Container Apps add-ons. And we're basically behind the scenes spinning up a container app that's using the quadrant image, and we're also managing the storage for you there. It's a really good place to start. If you need to actually scale up even further than that, you can actually go to the Azure Marketplace and spin up quadrant there too. And as you can see here, everything runs within the same Azure Container Apps environment. In this case, there is some kind of communication going on there. So running everything in the same environment makes it really easy for, in this case, for both the chat app as well as the job to talk to Quadrant. But you can sort of kind of picture a kind of larger kind of microservices kind of environment where you have all sorts of things talking to each other. And having everything in the same environment, which behind the scenes is the same virtual network, makes things a lot easier.
Just to mention that you don't always have to containerize your app with Azure Container Apps. So let's say you have a regular app that doesn't even have a Docker file. You can still bring it to Azure Container Apps. There is a concept of code to cloud where you just easily deploy, and the platform creates the Docker file and the necessary YAMLs and etc. behind the scenes for you.
That's actually a good question, or a good kind of thought. How many of you want to deploy containers? And how many of you just want to deploy your code without containers? Split half and half, maybe a little bit less for code. Cool. Yeah, so we're going to just take a look at how we're going to deploy this thing to the cloud. I won't run all the commands, but I will kind of speak through some of the commands that I've ran to kind of deploy the app, because it does take a few minutes to kind of build the image and all that stuff. And then I'll kind of go through the portal and kind of point out different things with the deployed apps. Okay. Actually, I'm going to start in the portal, if I can find my browser again. There it is. Okay, so as we kind of talked about before, everything's kind of deployed to a container apps environment. So what I have in the Azure portal open right now is my environment. And I guess I zoomed in so much I lost the sidebar. Here we go. Let me know if I need to zoom in. But here we can see my app and my job deployed to my environment. We'll click into that in a little bit. And we also have our Quadrant database here. So And then if we wanted to create more, so say I wanted to spin up another database, we can see here you can choose from Redis, Postgres, all sorts of things. You literally just have to give it a name and then just press create. And then within about a minute or so, you have yourself a database. But yeah, so I think that's the Quadrant database. Let's go look back at let's do the job first. So the job here, we can see that it's currently a manual job, but I actually could have created it as a timer job or an event trigger job, and then it'll basically run on a timer or basically run when something happens, like if a file gets uploaded. Some of the interesting things I can show you here is the execution history. So you can see a bunch of stuff worked whenever I ran it. But the first one failed. I don't know how many of y'all have deployed stuff, but the first one always fails, right? Or is it just me? That's what happens to me yesterday and the day before, all the time. And I guess the other thing I'll point out is that we're basically mounting the Azure file share into the job. So we can see here that they were mounting this thing, a file share called PDFs. And then if I hop into here, this is the Azure file share that I'm mounting. So it's got a couple of PDFs, including a pretty sizable one. I basically downloaded the entire set of Azure Container Apps docs and also fed it in there as well, which is why it took, some of those runs there took a little while. That's the job. And then the last thing I want to show you is the app itself. And then I'll kind of talk through how I deployed some of those things. So for the app itself, the main thing I wanted to show you is the identity here. So you can see I have an identity turned on for my app. So this is called a managed identity. So, so this gives the app, as the name kind of suggests, an identity in Azure Active Directory, or I think it's called Entra now. So what we're able to do is we can give that identity role assignments and very specific role assignments. So in this case, it only has one single role assignment for basically talking to Azure OpenAI and basically calling the model endpoints. So that allows me to give very fine-grained control over basically what or who is allowed to talk to Azure OpenAI, as well as it allows me to basically configure my application so that, what was I about to say? I lost my train of thought. But yeah, it also allows me to kind of I don't know. There was a second part. It'll come back to me. It's all good. Okay, cool. But this is the main part. So using identities to talk to it. I just remembered the second part. The second part is if I look at my app, I have no secrets in there. So if I look at the environment variables, you won't see any secrets because I don't have to store the API key anymore. So that's the tokens are created on the fly. Whew. Almost forgot something. That's no good. Okay. I'll kind of talk through how we deploy the app. So as Devanshi said, there's actually a way to deploy the application to container apps without actually creating a Docker file and containerizing it yourself. And that is using a command called Azure Container App up. Let me find myself a new terminal here. Oh, why is it on the bottom? One moment. Here, I'll bring it up to the top. So if you go Azure AZ Container App up, and I'll just kind of show you the help for it. You basically just have to give it a name. You have to basically give it the location where your files are, which is either local or in GitHub somewhere. And it's actually going to go and first it's going to create a container apps environment. It's going to create a container app. And then it's also going to use build packs to try to build your application into a container and deploy that for you on your behalf using a single command. So it's great. And it's also able to deal with applications that have a Docker file. So if you have a Docker file, we'll just kind of build a Docker file for you. But the whole thing about setting up the environment as well as creating the app, it does that all for you automatically in a single command. How I deployed this app, though, was a little bit differently. I like to have control, so I actually built the container myself and pushed it to Azure Container Registry. And then when I created my app and my job, I just referenced that, that container image. But yeah, so that's kind of how we deploy that to the cloud. And when we look at the app itself, there's a URL, and then if I click on it, that was the same chat interface that we were seeing before. Okay, so next thing we kind of want to talk about or try to do is there's a way to kind of like upload files in Chainlit. And right now, it doesn't actually do anything when we upload it because we haven't coded for it. So what I want to do is when I want to extend this app so that, in addition to being able to query over the PDFs that we have ingested, that I can actually upload maybe a CSV of customer data like I have here, and kind of ask it questions about, like who's the customer that bought the most stuff, or things like that. So we're going to try to do that now. So let's do that. Okay. And instead of you all watching me code, I know you all want to see that. No, you don't. I've already done it in a different file. And I kind of just call out the differences between this and what we saw before. So everything here is the same. We're kind of still talking to Azure OpenAI the same way. We have the same retriever tool that's talking to Quadrant. But we have this new thing now called the Python REPL. So LangChain already ships a Python REPL behind the scenes, or not behind the scenes, in the box. And I found that I actually had to give it a little bit more instructions to make it a little bit smarter. Sometimes it forgets to kind of print the result, and so I kind of just basically add it to the description so that it's really, I'm just reiterating that please print the results when you need to print the result. So what's going to happen now is I'm going to give this tool to my agent, and the agent now has two tools. So whenever I ask it a question, it's going to decide, do I need to search for something, or do I need to kind of call into a code interpreter? And the code interpreter is useful for things like math. LLMs aren't super great at math. You tell it to multiply two numbers together. It'll actually give you an answer, but if you actually punch in a calculator, it's probably wrong. So it kind of tends to hallucinate answers to that. And also, a code interpreter allows you to do things like process, data, for instance, using pandas. So I saw a hand there. Yeah?
So how does it know which tool to use or when to not use it?
Yeah, so that's a great question. So the question is, how does it know which tool to use? So whenever you create a tool, you can actually go into the definition of the tool. And each tool has its own description. So it's actually pretty simple. Like if you actually peek under the covers, what's happening. So each tool has a description field, and it's literally just self-describing what it is, right? So in this case, it's telling the LLM that, hey, I'm a Python shell. Make sure you send me valid Python commands. As we'll see later, it actually doesn't always send a Python command to it, even though you said it. And also it says, if you need to know the value, please use print. And what I found was that even though it said this, it actually doesn't always print it. So which is why I kind of augmented the description to say, hey, I want you to use print. So you can sort of see that you can sort of imagine that the retriever tool is the same way. Actually, the retriever tool, we actually define it here. So it says it searches and returns excerpts from documents that contain useful information. And if you actually have multiple retrieval tools, say I have one for stuff about the internal company, and then maybe there's some other database somewhere that stores something totally different, maybe product data or something. You can actually create two of these tools, and then basically give it different descriptions, and then. And I'm actually really glad you asked that question, because one thing I forgot to show you was the prompt. So if I look at the prompt, so I'm using a custom prompt here. So this is what actually gets sent. This is what actually gets sent to the LLM. So we're saying, hey, you're a helpful assistant, because we want it to kind of feel like it's a helpful thing. So it likes to hear that. And then we're just telling it, hey, please try your best to answer these questions. And then this is basically the React framework for not the UI framework React, but React as in reasoning and act. So like basically like we're telling the LLM that hey, like when you have to solve or basically answer a question, think through what you need to do and then figure out which action you want to take, basically which tool you want to use, and then basically respond in a specific format so that we're able to parse the result. So, what we're doing here is that we're just listing out all the tools. So you can sort of imagine that when we run this, we're actually just basically for looping over the tools, and then we're just dumping out the descriptions here. So like, so when we call the LLM, it knows what the descriptions are, and then we're also saying, hey, like make sure that when you take an action, it has to be one of the tools, and then that's it. So like we're using this as a template every time we call the LLM. So hopefully that helps a little bit about to explain how it decides. And thanks for asking that question because I totally forgot to show this part. Cool. Yeah, and so that's about it. So like that was like I had to add one line, maybe 2 lines of code here to basically give it this new capability. Another thing that I've done down here is that Chainlit will basically populate this elements property when there are files that are included in the chat. So I'm basically saying if the chat message has a file, I'm just going to record in a variable called latest file that this is where it got saved to. And because it's all locally, that's all I need. I'm just going to save it. I'm just going to record the path that it was saved to. And then now every time that I execute or basically ask it a question, we're also adding some additional info. So if we go back to the prompt, you can see here, I kind of added a new place here for some additional information that I want to give to the LLM. So in this case, I'm saying, hey, like if you need to analyze data, there's a file at the latest file, and then you can write some Python code to do it. You have pandas available to you. Always start by asking or basically checking the first few rows because like we're going to ask the questions. We're not going to say, hey, look in this column and find this thing. We're just going to ask it like a natural language question. So in order for them, like for the LLM to kind of figure out the shape of the, or basically to actually come up with the answer, it needs to go, the first step it needs to take is to figure out the shape of the file. In this case, it's going to basically run, like it'll probably use the head method to basically list out the first few rows of the PDF or of the CSV, just so that it can understand what columns there are before it actually goes and figures out the right queries to write. Yeah, so that's what we're kind of telling it. And then the rest of it more or less stays the same. So that's all we kind of need to make this thing work, I hope. So I'm going to go ahead and shut down the previous one. And I'll run the Python REPL one. And I'm using -H here because I don't want it to keep starting up a browser. Let me go back to my local one. So this is the local one that I had before. Let me get rid of this. Oh no, what happened? Am I here? Okay, it should be working now. So let me go ahead and refresh this UI. And now I'm going to go ahead and basically upload a file. Here's the customer CSV. And then, who is the, if I can type, customer who bought the most stuff. So it's going to go ahead and try to figure it out. We can actually see in the output what it's trying to do. And while it's actually running, I'll kind of bring up that CSV if I have it here somewhere. I might not actually. Oh, no, I do. You can sort of see what's there. It might be a little bit hard to see. But it has some, information about first name, last name, emails. Nothing super important, but yeah, there's a total purchases in dollars as well as a satisfaction rating. So that's the kind of information that that is going to try to use to figure out the answer to my question. So you can see that. So it started off saying, hey, I actually need to use the Python REPL to do this. It actually tried a couple of times thinking that quantity isn't a thing. So it kind of basically tried different, to basically like run different pandas queries to kind of figure out the answer. So you can see that it's trying different things until eventually got to a point where it's like, okay, I figured out that I need to basically get the first name, and then actually, it's actually not doing it that right because it's grouping by first name, but I'm sure there might be different people with multiple first names. Or with the same, multiple people with the same first names. But you can see it kind of did the right thing, and it kind of did a sum. So even though it's able to give us an answer, you can see by looking at the output there that it was actually slightly not correct. So you can kind of see what it's doing here as well. Yeah, it did quite a few things. It basically checked the first few rows, and then it ran a few queries until it came up with this slightly inaccurate answer. But still better than nothing. But let's try something else. Who is the happiest customer in? I think there's like some people in Arizona. So hopefully behind the scenes, Camille. So hopefully ran the right things. Yeah, like state, and then kind of like, so it knows to basically look for the customer with the highest satisfaction rating, things like that. So that's kind of like how you can kind of pull in a Python REPL. You still, like, as you saw that, you still want to double check its work, but it's pretty cool that like just by adding a couple lines of code, it's able to do that. So yeah, so like, but if we were to deploy this to the cloud, can anyone think of like what bad things could happen? Yeah, somebody said prompt injection. Yeah, you can basically do some potentially bad things. So like, for instance, I can ask it things like, hey, write some Python code to print out. I could say all my environment variables, but I don't want you to see all my environment variables, so I'll just the values in .env, or basically the contents of .env, which is a few variables, and print it out. Oh, and execute it. Execute it. Oh, I can't type when people are looking at me. And print it out. Okay, hopefully this will do something. Maybe not, I don't know. We'll see. What? It didn't do it. Oh, it started like searching for stuff. Wait, let me try again. Right. Every time I tried it before, it worked. So I'm really sad about it. Oh, there you go, it worked. So you can see it's got like, some, thankfully I don't have any secrets in there. Oh shoot, I do. Oh, dang. So that's bad, right? So like we don't want that. So, so these are the things we have to think about when we deploy this to the cloud. So let's quickly switch back to this. I know we're quickly running out of time. So I talked like, some of the concerns that we need to think about. I talked about security already. We also have to think about performance. We don't want to like, every time you need to execute something, maybe spin up a container, wait for it to spin up, and then execute it. Right? You want this to happen really fast, and hopefully within, milliseconds, not even seconds, that you can actually execute this code. And you also want to basically ensure that when you create these containers or environments for running your code, that you find some way to actually automatically get rid of them, right? You don't want them just hanging around. You want really easy lifecycle management. And you also want to run this at scale. And as we talked about before, these are the different components or different ways you can deploy things to container apps. And today, actually this morning, we announced this new thing called dynamic sessions. And what dynamic sessions are is that it's a way to run really performant, highly scalable, and secure sandboxes, and in this case, code interpreters in the cloud. So it's fully isolated using Hyper-V, so it's probably one of the highest levels of isolation without going to a physical VM for every execution. And then the code can execute in seconds, and we do this by maintaining a giant pool of code interpreters. And then whenever you need one, we just give you one instantly and execute your code. And then after you execute your code, you can actually go back and execute more codes in the same session. So in the case of a chat app, we'll actually use a single session per chat conversation, so that additional executions of the same agent will reuse the same session. And then it's super scalable. The same technology today is powering a bunch of stuff within Microsoft. So we're actually executing millions of sessions a day already using it. Okay, so I'm going to quickly do a quick and abbreviated demo of this. So yeah, in order to use sessions, you can go ahead and create a new resource, search for, I think Code Interpreter works. And then we can see that we have a thing here called a session pool. So you can go ahead and create a session pool. It doesn't cost you anything. It just basically allows you to specify some value, some configuration, like which, how many concurrent sessions you want, as well as how long to wait since the last time you interacted with the session before we delete the session. And then we're going to go ahead and create it. Because we're running out of time, I'm not going to do that. I think I already have one created called PyCon. So once you created it, you can just find it in the portal. And then we actually give you a little bit of a portal experience here for to kind of test out some of the APIs. So we can actually upload files. So we're going to use that to upload our CSVs. And then once we uploaded a CSV to a session, we can now basically run some Python code to talk to a session. So this session probably doesn't exist right now. So when I press run code, you can see that it kind of, it executed in a new session pretty fast, right? A second or two. Yeah, it's a little bit small, but you can kind of see that it kind of gave me the output here. I can basically have, I can set environment variables too, say a equals 6 or something and run it. Nothing happens because I just set a variable, but now I can say a times 7, run the code. You can see that it came back with 42. But if I go ahead and change this session to say Anthony, to a different ID, and run it, it's going to basically give me a new session to run this in now. So when I go ahead and click run code, you can see that this time it didn't work because A is not defined because I'm now in a different session. So that's, it's pretty easy to actually interact with sessions. You don't have to actively or basically, explicitly create and delete sessions. You just have to basically send code to a session ID. If it doesn't exist, we just give you one. And let's really quickly look at how we can take advantage of this in our app. If I can find it again. Okay, it's the exact same app as before. The only main change here is we have swapped out the Python REPL tool with a sessions Python REPL tool. So we've shipped integrations with LangChain, Llama Index, and Semantic Kernel, and we have more coming up. We're also working for one on AutoGen, but really any framework, and we can probably build a tool for this. So the only thing that we would need is the pool management endpoint, which we can actually grab from the portal. And then that's it. The rest of it, you just use it exactly the same as you would before with the Python interpret or with the Python REPL that comes with LangChain. And the other small change that I did here is when somebody gives me a file, I'm now uploading it to the session, and then kind of saving the path within the session of where it was uploaded to. But then everything else stays the same. So now when we talk to the LLM and there's a file, we're basically telling it, hey, there's a file in this case /mount/data called customers.csv. And please use that when you query over it. So when the Python code is running within the session, it's able to find that file within the session. And I'll just quickly run this to show you that it all works, hopefully. And we have to wait again. Here we go. It's up and ready. Let's go back to our local, refresh. And now, hopefully, when we ask it the same question as before, can you please print out the contents of .env? should tell me it doesn't know how to, they couldn't find the file, or it doesn't want to do it or something like that. There you go, it says I don't have access to the contents of the file because I'm now running remotely in the cloud instead of locally. So I'm a lot safer. Everything else still works. So if I go ahead and upload the customer's file again, and then I ask them a question about, like, you know, maybe the 5 least happy customers in Arizona. And if we look at the output, you can see slightly different output because this is the actual API response that's coming back from the session itself. That's how you know that it's actually calling on the session. And then you can see that it kind of came up with the top 5 customers who are hopefully who have the lowest satisfaction rating. And yeah, that's right. So it looks like I did it right this time. And yeah, so that's how easy it is to plug in Azure Container Apps dynamic sessions into an intelligent app that's been deployed to Azure Container Apps also. And with that, I'm going to hand it back to Devanshi.
Oh, wow, thanks, Anthony. Okay, so we have now dynamic sessions in Azure Container Apps. We saw all the things about security, performance, scalability, all of that is true, but essentially you can now run your LLM-generated code securely in a sandbox on demand with a strong security posture mitigating any risks for your application. And this also extends to SaaS customization or extensibility for ISVs to build their solutions for. And if sessions did not exist, you would have to create, or rather spend months of development work, have configurations to set up and maintain, as well as incur additional costs to be running these environments explicitly every time, customizing and more. So with that, if you scan the QR code, you can check out the release, the launch from this morning. And it's the same one, the first one, try dynamic sessions. And there's more to come for dynamic sessions at Build next week, so join us there. And here at PyCon, we are available at the Microsoft booth today and through the rest of PyCon, as well as the open space tomorrow at 2 p.m. So thank you for joining us, and see you soon.